Hello, this is section 4.3 diagnostics on square regression line definition. So coefficient of the determination S square measure the proportion of the total variation in response variable that is explained by the least square regression line. Coefficient of determination is a number between the 0 to 1. And then if the r square equal to 0, then the line has no exponential value. And then r square 1 is the mean that the line explains 100% of the variation of the response variable. So example 1, the computer interpret the coefficient of determination. So data are based on the study of the drill and log, which is we did earlier. And the researcher wanted to determine whether the time it takes to dry drill distance of the 5 feet in a rock increases with the depth of at which the drilling begins. So depth at which drilling begins is a predictor variable x, and then time is going to be the response variable y. So these are the limit for the drilling begins, and then this is a feet depth, and then this is a minutes. So and then this is actually a scatter plot that I just put it. So I already give you the depth as a mean and time as a mean here, and then the standard deviation for the depth and then time. So if you're using those to find the correlation, will be the 0.773, and then regression analysis that this is what we got here. So this is actually the y equal to the 0.0116x plus 5.53, and then x represent depth, and then the y represent the time. So example 2. Suppose we were asked to predict the time to drill the additional 5 feet, but we did not know that the current depth of the drill. What would be the best guess? So we just need to use the formulas, okay? So before the formulas, which is when you look at it, you can just say as a mean time. So the mean of to drill a additional. So this is gonna be observed information. So 5 feet is 6.99 minutes, right? That's what I got here, right? And then when you try to actually use the correlation to find the equation, so now the example 3 says that now suppose that we are asked to predict the time drill on additional 5 feet if the current depth is 160 and 160 feet. So this case is, I think we can just use the equation we got it using the correlation. And then this means actually the increased from 6.99 as an average to the 7.39 base of the knowledge that drill depth is positively associated with the drill time. So regression plot that I'll show you as a graph on the next page. So on the next page, regression plot. So we have those are kind of the equation. Okay, and then this is the equation of the line that we made it as a coloration. And then this is going to be the difference unexplained by drill depth about here. And this is going to be the difference explained by the drill depth. So difference between the observed value and the response variable, and then the mean the value of the response variable called the total deviation, which is this. And the difference between the predicted value, so this is the observed value with the mean value, and this is about the predicted value. And then with the explain deviation, this is we call explain deviations. And the difference between the observed value of the response variable and the predicted value, and then we call the unexplained deviations. Okay. So it explains on the graph said that so unexplained variation is from here to here, and the explained deviation is going to be here to here, and this is actually the total deviation, which is y minus y bar. So total deviation, unexplained deviation plus the explained deviations, and then total deviation is unexplained deviation plus explained deviation. So which is we can get everywhere. There's more points than that. And so and the variation is unexplained variation plus explained variation. So the total variation is, you can just say 1, and then you are putting as fractions, and then becomes that r squared is actually the ratio of the explained variation to the total variation, which is you subtract from the 1 from the unexplained variation and total variation, and subtract from the 1. So determine the r squared is a linear regression model, simply square of the value of the linear correlation coefficients. So, but you gotta be careful. The squaring the linear correlation coefficient is obtained. The coefficient of determination works only for the least square linear regression. So model of this one. So we did the last sections. So find the interpreter coefficient determination for the drilling data on this case. So because of the linear correlation coefficient, R is 0.773. So we know that R squared is going to be 0.773 squared, which makes 0.5975, which is the same as 59.75%. So for the interpretation percent of the variability in drilling time is explained by the least regression line. Okay, all right. So that's for the 4.3.